Good afternoon, everyone, and welcome to the webinar from Alphasense Robotics about the announcement of Alphasense Position. So let's wait a few seconds to make sure that everyone wanted to join the meeting is connected and ready to listen, and then we'll get started. So, all right. Well, as you can see, it's time for VisualSLAM. In the past few years, wandering in fairs and talking to people in the industry, we always heard vision is the future. And we at Alphasense, we believe that actually we are actually VisualSLAM is ready now to be on the market, and we want to show it to you today. So here from Alphasense in Zurich, I'm Gianluca, presenting to you this webinar, and together with me there is Marcin Dimczyk. So I'm a co-founder of Alphasense and leading business development activities.
So hello, I would like to also say hi. My name is Marcin. I'm also a co-founder of Alphasense, and I'm taking care of product.
All right, for those who might not know about Alphasense, so at Alphasense we build eyes and brains for mobile robots to make the robot smarter than ever before. And what you can see in this picture is a bit of a vision of the future, where we see mobile robots moving around in public spaces next to people with the flexibility that nowadays we see only in the futures, in the movies, but we believe that this is possible. Nonetheless, today the challenges for mobile robotics are elsewhere, in the professional cleaning or in material handling, whether in warehouses or on production floor. There are several challenges that needs to be tackled, and VisualSLAM can help. But what is VisualSLAM? So you might have heard several times already about SLAM. SLAM is simultaneous localization and mapping. And this is a technique that is used by mobile robots to understand where they are positioned when operating. In particular, robots need to map the environment and then find their position within this map that then will be used to decide where to go. And you might have heard SLAM together with LiDAR or laser SLAM. And this is a technique that is now available on the market for several years. And what we are bringing to the market instead is VisualSLAM. And you can see here that actually there is an inertial element that is sometimes forgotten. So visual inertial SLAM. What does it mean? So basically, visual inertial SLAM is a concept that is inspired by how humans actually work and how people understand where they are in their environment. Specifically, people use both the eyes and the sense of equilibrium that lies in their ears to really understand how they are positioned in their surrounding. Seemingly, a robot can use image sensors or cameras and the motion sensors embedded on the vehicle to collect the same information. Now, let's look at this map. So this is a top-down view of a 2D LiDAR SLAM map. You can see these very nice, sharp edges that define a contour of the building. So you could definitely overlay this map on a CAD model of the building, and this really corresponds to the blueprint of such an environment. You can see, you can distinguish really all the different environments in a very clear and distinct way. At the same time, you understand that if you are a vehicle and what you see is this map, it means that you can perceive only a single slice of the entire environment. This is sufficient for many tasks, but sometimes this might not be enough. 3D VisualSLAM instead allows you to define a map. You can see here on the left side. So this is a top-down view of such a map. And also here you can see all such well-defined structure that was recorded while moving a vehicle with embedded VisualSLAM into a warehouse. This map was recorded in 30 minutes. Now you may wonder, literally, it took 20 years of worldwide research in VisualSLAM to develop such a system. What is the difference with the image we have seen before? Now, we have seen before that 2D LiDAR SLAM detects a single slice. With 3D SLAM, we capture the entire thing. A lot of information that can be used for several purposes. And specifically now, you may ask, why do we actually need VisualSLAM? In fact, there are several applications nowadays that are working perfectly, and they constitute state-of-the-art into the material handling industry. If we look, for instance, at line supply and kitting, line following is doing a great job there. It is accurate as much as it needs to be. It handles the dynamic environment. On the other hand, the setup cost of such system is very high, and also it takes time and labor to install all the lines. And the layouts that are generated during the installation are definitely not flexible. In another case that constitutes state-of-the-art techniques in material handling, in automated material handling, we have end-of-line handling, for instance, where large pallet trucks are transporting goods from the end of a line to, let's say, a storage. And again, to pick up a pallet, you need to be accurate. And that's what laser triangulation is very good at. It's very accurate. You can also handle dynamic environment. Since laser triangulation works with reflectors at height, it means that anything happening below the line of sight of the LiDAR, it actually doesn't affect at all the navigation capability of the vehicle. On the other hand, the setup cost also in this case is very high. It takes a lot of time to install, to calibrate the entire system, to define the map and the layout of the system, as well as the reflectors that need to be installed all over the place in the operating environment. Regarding the flexibility is definitely higher than the previous case, but at the same time, you might need to add more reflectors. You might need to add more features in your map in case you want to move beyond the area that you have been using so far. Next, we have also another process, inter-process connection, where the most advanced of our laser SLAM technology based on natural features is widely used. Why it's a really good solution? Because it is accurate, the setup cost is very low, and is very quick and easy to install. And at the same time, again, you do not rely on a specific path or predefined line, so it is flexible to adapt. But at the same time, you have seen what 2D LiDAR SLAM relies on, this map, this blueprint. What if anything changes in this blueprint? Then the robot may get confused. This means that dynamic environments are not the best place for such a technology. But then we have seen that we have complementary characteristic for all these different technologies. But can we have it all? There are several applications out there that are still manual and cannot be automated because of the limitation of the existing technologies that we have seen. Accuracy below 1 centimeter, the possibility to handle dynamic environments, low cost for the setup, and especially the high flexibility. This is extremely important in warehousing activity as well as in modular production processes. So with 7Sense VisualSLAM, we are actually matching. We are actually bringing all the benefits, all the key benefits that would enable a solution that covers all the aspects that we have seen so far. But there is something more to this, because with as we said, with VisualSLAM, we enable a third dimension. And this third dimension brings along other benefits, especially regarding the robustness. Any occlusion, since we can detect the structure and the environment on the entire 3D area surface, we can basically, we are resistant to the occlusions potentially in some directions of the vehicle. So if you need to pick up, for instance, a pallet, and we have a vehicle passing beneath it, we will not be bothered at all if there are any wheels or any other occlusions really that are obstructing the viewpoint of the cameras. Also, ramps and uneven floors, these are huge limiting factors for several of the AMR and AGV vehicles that either in production need to move from one area, one building to another building, or even if they need to move over ramps, or potentially even on multiple levels, right, connected by ramps. 2D LiDAR-SLAM and generally LiDAR-SLAM have a big limitation in this regard. And this is tackled by the full 3D power of VisualSLAM. Next, we have also the global localization. This is a concept that is missing completely in the existing technologies. Basically, the possibility of putting a robot anywhere in the operating environment and starting up and expecting it to move. This is a breakthrough change in the industry because it doesn't only allow really to use in a very flexible manner, operate in a flexible manner all the vehicles, but at the same time, whenever a vehicle loses its position, for instance, it doesn't stay blocked. It doesn't need any support because it's just able by itself to recover its position thanks to the power of our algorithms. Last, and only because of the lack of further space, we can say that the outdoor navigation capabilities is another huge feature of VisualSLAM. Since we are not affected by the limited field, the limited range, sorry, of the laser, we use a passive sensor that allows vehicles to really navigate seamlessly, both indoors and outdoors, and transition around them. So I think that it should be now clear why VisualSLAM is the future, but I'll pass now the word to Marcin to explain how this is possible.
So thanks a lot, Gianluca. So now we are more or less understand why VisualSLAM is making such a difference for mobile robotics, why it's changing industry, and why it can open up completely new applications, but also revolutionize the existing ones. But obviously the question that remains is like, how does it actually work? And how is it actually possible to use cameras, multiple cameras mounted somewhere on the robot to reliably tell where it is? So I would like to start with a real use case, a real example. And let's think about like a large, repetitive, and very quickly changing space, something like a warehouse that you can see in the picture, where the pallets, the products are constantly moving in and out. So the structure of this environment, particularly close to the floor, particularly at the slice where 2D LiDARs operate, is changing very, very quickly. And it's extremely challenging to fully automate the operations in such environment. So let's think about the VisualSLAM in such use case. So let's start assuming that we have a robot equipped with multiple cameras, equipped actually with Alphasense Position, traveling through this environment and building a 3D map of this environment. So basically preparing and getting ready for operations of Alphasense Position in this environment. So on the left, you can see a picture of this environment, but on the right, you can see how our robot sees this. And the cameras mounted on the vehicle are seeing the environment from the perspective of the robot together with certain key points and characteristic points in the environment marked here with colorful circles. And those points are actually used to build them up and to track them when the vehicle is moving and when the vehicle is also visiting the same place again. And by tracking those points over time and across visits, we are able to tell very precisely where the robot actually is. So assuming we can track those points when traveling through the space, we can build a 3D model of the environment. So we are tracking those natural features to build a 3D model of the environment. And on the right, you can see a visualization of the actual map building process of our vehicle. So you can see the robot, and you can see a bundle of yellow rays going into different directions. And this is exactly what Gianluca was talking about. So the cameras mounted in different directions, so both to the front, to the sides, and upwards, are observing different features of the environment, not only at this very low level, but also higher up and also in the ceiling, to build a 3D map of the environment that covers all possible directions. And this map is actually built not only using visual information, but also using the sensor fusion engine that we have, that combines it with the IMU, so basically with inertial information, and the wheel odometry signal, so the signal from encoders of the robot. So those rays, the more we have of them, it means that we have a better understanding or better picture of the environment around the robot. And in the end, they result in building a 3D model of the environment that is shown here in green. So basically, it's a 3D digital twin of what the robot registered. So taking it further, you can see that by just traveling through this environment and building this 3D model, we end up with a full and metric map of the environment. And I would like to emphasize here two important facts. I said metric, and it's not a coincidence. So this map is actually a proper geometrical representation of the environment, in a way very similar to the contour maps, if you look top down, of 2D LiDARs, but it's actually a full 3D map. Secondly, the important thing is that it's a ready-to-use map. So compared to many other systems, our map can be completely autonomously post-processed by the robot, and is ready to use minutes after collecting it, without any manual or human intervention. So there is no map cleanup, and even the operations at this plant don't have to be stopped. Everything else can go as usual, and our robot collected this map on its own, and it was ready to use after a few minutes. So in the end, that's a top-down view of this map, but let's take a look. You can get a full 3D picture of this warehouse, starting from the floor level up to the ceiling. And what's very important about this is that this full 3D model of the environment not only permits us to estimate the robot's position in full 3D, so I'm thinking about ramps, I'm thinking about not even floor, but also it gives us high resistance to changes in geometry, so basically moving pallets in and out, moving products in and out, and appearance. So by registering features, those natural features all around the robot, even if something changes at the robot level, we see many other features and enough features to still stay positioned very precisely. So taking this process on a bit more abstract level, this diagram represents the key benefits of VisualSLAM and how it works in the material handling use case. So first of all, it gives us a chance to handle dynamic environments. Second of all, it gives us a possibility to handle ramps and non-flat paths. And third, thanks to this all-around view of a 360 view, it gives us a possibility to work both in and outdoors, and also transition from in to outdoors seamlessly without any issues, range limitations, or problems, for example, with sunlight. So taking it all together, it really sounds great, but let's now think a bit in the product aspect. So we would like to invite you to say hi to Alphasense Position. So it's a product, it's a VisualSLAM product from 7sense that includes all this VisualSLAM technology in a box. And that's why we think about it as a VisualSLAM in a box system. So basically a complete package, which includes both hardware and software to bring you this VisualSLAM experience and this VisualSLAM benefits directly to your robot. Let's think about specifications. So that all sounds great if we talk about concepts, but what does it actually bring? So first of all, the system brings excellent repeatability, and this has been confirmed already by our customers during various evaluations. We have measured 4 millimeter mean precision error of the system, which makes it possible to navigate very precisely, but also to dock or charge at some stations. It brings the global localization without any prior, so something that Gianluca already mentioned, which permits to start operations anywhere in the map. So you don't need to read any text, you don't need to read any beacons, but you can basically drop the robot anywhere in the map and start operating. What is important here, it's basically also called a kidnapped robot problem, which makes it really easy to just reset or start the robot anywhere after, for example, a failure. The system can use up to 8 cameras. So we are flexible about the cameras, the number of cameras, we are flexible about the placement of cameras. And depending on the exact application, you can place them either in one sensor head or all around the robot. That really depends on the specific environment you are targeting. And finally, together with this visual engine, we are bringing the sensor fusion engine. So basically, the algorithms that bring the visual information together with the inertial information from the IMU and the wheel odometry. So thanks to that, we gain really great accuracy, but also robustness in case, for example, some of the cameras are covered. So we have also evaluated this, and we know that the system is extremely robust to the occlusions of the cameras. So now we would like to talk about the deployment of the system. So show you a quick demo video to understand how easy it is to deploy Alphasense Position. So we'll be looking at the process of creating the map using Alphasense Position. Our user can use a web-based interface to start mapping. It's an interface that we ship with our evaluation kit, but obviously it can also be done programmatically over an API. Our user can basically move the machine manually or using a joystick through the environment to record visual information about this environment. And you can see that using the cameras, the features are tracked in green, those circles in green in the environment, and then a 3D visual map is created, which is represented by the yellow rays in the map. And you can also see that the map is emerging. Now, our user is finishing this mapping process, and this autonomous post-processing step will happen, so no user intervention. The map will be refined, so you can see that the geometry is slightly adapted to become more precise. And what we end up with is like a 3D map of the environment that is literally ready to use. So that's how the deployment process looks like. And you can see that it's very seamless, meaning no expert knowledge and no manual cleaning up the map is necessary. It's enough to travel through the environment. Next, we would like to move to map sharing. So you can ask, okay, it's really easy to deploy the robot, but how can I take this from a single robot to a fleet of robots? So here we are showing like a structure of a system where we have robot, which is basically Edge AI, equipped with Alphasense Position, which can generate maps, but it can also get maps from a server. And using those maps, it can perform the localization process. The maps can be fed using Wi-Fi, 4G, or 5G from an optional server, so it's not really necessary. Some of our robots are completely working on their own. But this server can be either on premises or in the cloud, and it can maintain maps or also share maps to this robot or to many other robots. So this way, all the robots of a fleet will reuse the same map and operate within the same coordinate frame, which makes it very natural to use a fleet management system. The next extension, which is kind of obvious from here, is that can we actually update maps? So given this very rich camera information, if we see that something has changed in the map, can we also propagate this change to the fleet of robots? And the answer is yes. So if one of the robots is localizing within the map that it got either from the servers or that is stored locally, it can observe changes in the environment. It can notice when something new popped up and something has been removed, or simply if something looks different. Our algorithms, our VisualSLAM algorithms, can embed those changes into this map, and the map can be fed back over the server to the entire fleet of robots. This way, the entire fleet is using the newest version of the map, which stays up to date all the time. And the nice fact is, the more robots we have in the fleet, the more up to date the map is, because it's being constantly updated with every and single operation of each of the robots. So this reduces the need, or basically resolves the problem of the map getting outdated, which means after some structural changes on the environment or some local modifications to the environment, we don't need to remap it. It's okay if robots just learn those changes on their own. So now I would like to talk and switch a bit to the hardware, so from algorithms to the hardware, and talk about the variants of the hardware. So we offer Alphasense Position in many different variants, which vary from bare modules, so bare electronic modules that you can build into your robots on your own, to the cased versions, which are ready to install on vehicles, and some of them are even pre-calibrated. So we actually have some of them here, so you can see the base unit together with a single camera module that is waterproof and can be installed on indoor and outdoor vehicles, also dustproof. But also we have two versions of the pre-calibrated units, which can be used as an evaluation kit or can be used simply as the quickest way of deploying Alphasense Position on your robots. So they come with a fixed camera setup, which is pre-calibrated, which makes it really, really seamless to get it going. So now switching to interfaces. So communicating with Alphasense. So Alphasense Position implements a number of very typical industrial interfaces, which I'm sure you're using daily in your robots. So to communicate between your platform computer, whatever that is, and Alphasense Position, you can use UDP packages sent over Ethernet. You can use REST API for asynchronous communication. So basically to control Alphasense Position, start operation, or for example, check the list of maps. You can use CAN for synchronous communication, such as feeding in wheel odometry and feeding out the pose. And finally, you can ROS, which is pretty commonly used by research and development teams. Now, switching to the evaluation kit. So I mentioned a couple of times that we also have a version which is called an evaluation kit to make it really easy for you to check out the possibilities that are opened with Alphasense Position. So it comes in two different versions in terms of hardware, which is horizontal, vertical. We also have them here. So basically, that's a horizontal one. Next to it is vertical. The decision really depends on the configuration of your vehicle. What is important, they both come pre-calibrated and ready to use. And we believe that and we actually know this, that you can get SLAM working in less than a day. Together with an evaluation kit, you're getting support from the 7sense experts using a service desk, which means we answer all your questions, doubts, and help you with integration to reach the successful result. On top of that, you're also getting a web-based Alphasense Console tool, which is a user interface for the system to control it, using simply a browser from your desktop device or a mobile device. And what's nice about it is that it reduces the need to write some interfaces to the API of the system. So the only thing that you need is your mobile device or a desktop device to start operation, to manage the maps, to check how they look like. And apart from that, you just stream the wheel odometry in and you get the pose out from the device. So this evaluation kit has been tested on multiple vehicles. Here you can see a ClearPath Jackal robot together with the evaluation kit. And it's really as easy as it looks. It's basically two cables that you cannot see behind the evaluation kit and a few configuration options to get it going. About the Alphasense Console, so this web interface, I would like to show just the main screen of this console and highlight the key functionalities of the interface. So Alphasense Console permits you to see the status of the system, so to check if everything is working as expected. You can control the system, so you can start mapping to create maps. You can start positioning to localize within the previously created map. You can manage the device, so you can change the configuration, you can change the calibration, you can also manage the software versions or simply shut down the device. And finally, you can also take a look at the notifications coming from our device, so you can check what's going on, if anything was reported, if you can somehow optimize or improve the way how Alphasense Position is working. So this is particularly important during this initial integration and evaluation, where it's very, very important and very efficient to have a very good insight into the unit. So now I would like to sum up how Alphasense Position and VisualSLAM are working. So Alphasense Position works both in and outdoors, meaning we are ready to do industrial logistics and material handling applications indoors, but also outdoors. We support dynamic and large spaces, so even if the spaces are vast or are changing super quickly, that's not a problem for VisualSLAM. At the same time, we offer unparalleled accuracy, which goes down to few millimeters, which is extremely important for docking or certain operations. We offer quick deployment with limited downtime and very quick reactions and very quick results, in having a full 3D map of the environment. Then, Alphasense Position comes with a rich set of interfaces, which vary from very industrial-oriented UDP or CAN interfaces up to ROS, which is very useful for experimentation and development. And finally, Alphasense Position comes also as an evaluation kit that makes it possible to try it out really, really easily. So now, I would like to invite you to take a look at the product video of Alphasense Position.
Positioning is a fundamental skill that makes autonomous mobile robots reliable. However, current positioning technology is not flexible and robust enough for what the industry needs. These limitations are overcome by 3D VisualSLAM. We used cutting-edge VisualSLAM technology to build Alphasense Position, the most advanced positioning solution for robotics OEMs. Mounted on mobile robots, it allows them to always know where they are, precisely and reliably, even in the toughest environments. With Alphasense Position, navigation outdoors, as well as in dynamic, repetitive, or large environments, is not a challenge anymore. Creating maps is easy and fast. It requires no external infrastructure nor expertise and minimizes deployment downtimes. This gives high flexibility in defining the setup and keeps installation costs low. The system never stops learning. It keeps updating the map so that it can work in environments that change over time. The updated maps can even be shared across a fleet of robots. Alphasense Position combines sensor fusion AI with our multi-camera solution. Up to 8 cameras can be installed anywhere on the robot to fit the target application and provide a full surround view. It is also available as an evaluation kit to accelerate the development of new robotic vehicles. To overcome your localization challenges in tough environments, Alphasense Position brings VisualSLAM to your robots, making them smarter than ever before.
So, well, thank you, Martin, for introducing Alphasense Position. It's really a great product, and the VisualSLAM that we have seen in action in the video is actually running on several robots. We have been testing it a lot for many, many hours, both with the most advanced research institutes based in Zurich and elsewhere in the world, and with industrial partners. So we have our system well developed, and right now, Sorry, I need to get to the right slide. Okay, so, and as I said before, so as I said at the beginning, sorry, we are really focusing on material handling vehicle, professional cleaning vehicle. These are the two main industries where we see the strongest potential for Alphasense Position and 7Sense VisualSLAM. In particular, we can say that we have already been working with the top international players in the material handling field, both in Europe and Japan and USA. And we cannot disclose them yet, but we can say that sorry, this is an exciting journey for us, and we are looking forward to see this deployed in the real world very soon. Where we can see already Alphasense Position in the real world instead is in the outdoors delivery world. So we collaborated with Keyboard Switzerland for development of a postal delivery robot you can see here. And as well, you've seen several images of this already. So in the professional cleaning sector, we collaborate together with Vetroc on Marvin, their first autonomous scrubber dryer. And with this, we are wrapping up our presentation, and we are ready to take some questions. Of course, we all invite all of you to follow us on our main channels for communication. Please go to 7sense.ai and you can register to our newsletter, or follow us on LinkedIn, on YouTube, and on Facebook and Instagram as well, to see how 7Sense moves forward. Now, I would recommend, I see actually some questions. So thanks a lot, really, for contributing. And we can scroll through the different questions. So I see maybe a first one from Eric. Eric asks, how much effort is needed to build such a 3D digital map and deploy your system? So I guess, Marcin, you can address this question now.
Yeah. So thanks, Eric, for the question. So I think you probably asked it before even we have shown the video of how the system can be deployed and how to build them up. But maybe to recap once again, to build this map, you basically need the same sensor setup as is built into the robot, or the actual robot with the sensor setup. Just move it through the space, either manually pushing, as you could see in the video, or joysticking it around the environment. And this is it. After a few minutes, you're getting a 3D digital map that is ready to use. So it's really as simple as you could have seen in the video.
All right, thanks. Then next, I see some questions from Eric. So what is the sales model, purchasing or licensing? Maybe I seen something also below related to that, or yeah, cost of the test pack. Okay, there are a few. So first of all, regarding the model, so and the test package has only an upfront cost. So you can get, as Marcin described, the evaluation kits you can see here, either the horizontal or the vertical version, together with the software license, the access to the service desk, and also the possibility to use Alphasense Console, your web UI, for steering and simplifying the integration effort. So this is full upfront. While regarding the OEM pricing, for that we have a flexible formula that consists of both upfront payment and a subscription for the software license, including also all services related, like updates, software updates, and also technical support. And of course, if you want to know more for this, please reach out to us. You can go on our website, and there is a contact form. You can fill that in, and I'm happy to take it from there. Then I see a question from Marta. How does your VisualSLAM differ from competitors and open source frameworks?
So, yeah, I can take this one. So I think what is important, there are like a couple of aspects where the difference is particularly visible. So one thing that is very, very important for robustness and the quality of our system are the cameras, the number of cameras, the hardware we are using, and also the software that can take the advantage of this hardware that we are selling as a Alphasense Position package. So as you can see, we can support up to 8 cameras. This all works in real time. This prevents any problems with occlusion. They can look in all different directions. We can combine and orchestrate them right to estimate the position of the robot using all of those cameras. And on top of that, these cameras are really state-of-the-art, which means they are very resistant to changes in illumination conditions. They are also free of motion blur problems in usual environments. Then, on top of that, if you've asked, for example, about open source frameworks, the big difference lies in the robustness and the actual quality of the package. So we have an extensive suite of tests of continuous integration of testing routines when releasing revisions of our system to make sure they are up to standards, up to industrial standards when we ship them to our customers. So that's why we guarantee the real industrial grade quality of our system and of the results coming from our VisualSLAM system, which is definitely not that case for the open source frameworks.
Yeah, Marcin, thanks a lot. Don't give out too many secrets. So I see a question, another question for Marcin from Jen Jong. How robust can Alphasense handle environment changes in your map?
Mm-hmm. Yeah, that's a very good question, and it's a tough one because it's always a bit hard to say to what extent are large changes and what extent are small changes. What we can say is that we have tested Alphasense Position in many different environments, often over months, and you can think about grocery stores or warehouses which are changing daily, and Alphasense Position after deployment is operating without any issues. So I would say this is a really high degree of robustness to those environment changes.
Yeah, maybe we can add to this that the benefit of the also map learning over time really enhance the capability of the system compared to any other system available on the market, because as soon as the environment changes, our environment captures it, right? So if you have limited incremental changes over time that over time would result in a larger change, we would capture it on the way, and our robot would never get lost there. Next, I see we have several questions. That's great. So again, another question from Eric. Do we still need additional certified safety sensors?
So, I mean, what we can answer is that Alphasense Position is purely a positioning product, which means it only takes care of telling the robot where it is and not taking care of the full navigation of the robot, which means Alphasense Position on its own is actually not interfering with the safety system of the robot, which needs to be in place. What might be interesting for you, if you're interested in the full navigation product, you might reach out to us and we can chat about Alphasense Autonomy, which is another product of 7sense, which is coming soon to the market.
Yeah, in addition to this, I would say that overall, when safety certification are concerned, it really depends on the specific use case. For instance, for the professional killing machine, that we don't have, for instance, any safety certified sensor on board. We use a series of complementary sensor modalities from ultrasonic sensor, time-of-flight cameras in addition, which basically guarantee an overall safety of the system. Let's move ahead. So I see, how does the precision of your system compare to other LiDAR-based systems? Question from David for Marcin.
I can take this one again. So we believe it's a common misconception actually that LiDAR systems are more precise than vision systems. We have heard this worry, let's say, from our potential customers multiple times, and we must say that this is simply not true. So we have done really extensive evaluations with motion capture systems with different ground truth sources, both alone and done by our customers. And we can safely say that the precision of our system is easily on par and actually better than the commercial LiDAR systems used in industrial robotics. which means if you're expecting a precision, for example, to perform the docking, to charge the robot, or to reach the pickup or drop-off stations, you can easily do the same, or even better, with the VisualSLAM system, at least with Alphasense Position, I can say.
All right. So I see John liked our presentation. Thank you very much.
Yeah,
appreciate it. Jose Garcia goes straight to the point and convince me why I should switch to VisualSLAM from line following or LiDAR reflectors. Well, Jose, thanks for the nice question. We have seen it before, right? So we have seen all the comparison of different technologies, and at the end of the day, it really depends on the use case that you need to perform. If you we see a lot of we see a big trend in Industry 4.0, flexible manufacturing and production, and also collaborative environments with robots and people, where an extremely high degree of flexibility is required by the robots. And we have seen that those technologies present some limitations. So again, I'm not saying that you should switch today. I mean, I wish you do, but for sure, what I can tell you is that you have to reach out to us again and give us the opportunity to discuss better your specific use case. Then Cedric Schmidt, this is another question. I have trouble with AGV using a LiDAR SLAM system in block stack areas of my warehouse. Will your system do better? All right. Well, do you want to take it, or do I?
You can take it.
Okay, I can take it. So, well, you should have probably not. So the AGV in a block stack area is a challenging environment, first of all, because indeed you have pallets moving around. It can be there, it can not be there, and they lie usually on this 2D LiDAR plane. Definitely it would work better because we have a 3D perception of the environment. So we will not rely only on what work. Let's say what is changing, this palette shape that is changing and is affecting potentially the 2D LiDAR SLAM, or if you have a high pile of pallets, also this could occlude even the view of the 2D LiDAR that uses reflectors. So I think block stack area, those are great examples in warehouses of dynamic environments where VisualSLAM would excel. A question from Christoph. Do you plan to implement other functions besides localization, such as detecting obstacles or finding delivery positions in a block store?
Yeah, that's a great question. Thanks, Christoph. So the short answer is yes. So a long answer is with the capabilities of visual sensing and the cameras and the visual information that we are getting, which is not only a slice of the environment like for 2D LiDARs, but actually the full understanding of what is around the robot and this very rich information, it's a great chance to actually implement those additional functionalities. So yes, we are actually working actively on detecting an obstacle, understanding the environment around the robot. So really bringing this very good understanding of what are the surroundings to the robot, but also, for example, on helping robots to dock or reach certain positions in a block store to bring the maximum possible efficiency using the visual sensing. So yes, that's definitely on our agenda.
All right. So I think we managed to run through all the questions. So, well, I think that also we are hitting the time. So I would just like to present one last slide, and that again shows our contact form. So in case finish this webinar, you're still interested in knowing more, please go on our website, reach out to us, go on the contact form, and we'll get back to you and address all your concerns. And yeah, so thank you very much for your attention. It was a pleasure. Thank you very much, Marcin.
Thanks a lot. It was a pleasure from my side
And
too.
We'll keep in touch. So stay tuned on 7 Sense and follow us. Goodbye.
Thanks a lot. Bye-bye.